Have you ever wondered how a car works? Let's take a look at the major components of a car and how they work together to get you where you need to go. This is Crash Course: How Do Cars Work? Part 1. The Basics. Cars are complex machines with many parts that must work together in order to move the vehicle. But there are some basic components that all cars have in common. Let's start by looking at what's under the hood. An engine is the part of the car that makes the car go. In most cars, the engine is powered by gasoline or diesel fuel, which is stored in the fuel tank. When the driver steps on the accelerator pedal, it opens the throttle body, which allows air and fuel to enter the combustion chamber through the intake valve. Once inside the chamber, the mixture of air and fuel is ignited by the spark plug, causing an explosion that increases the pressure inside the cylinder. This pressure forces the piston down, which rotates the crankshaft, which in turn powers the wheels through the transmission and axle. As the piston moves back up, the exhaust valve opens and the piston pushes the burned gases out of the cylinder through the exhaust pipe and out of the tailpipe. Now that the cylinder is empty, the process starts again with more fuel and air being drawn in through the intake valve, and this cycle keeps repeating, powering the car forward. The engine needs a lot of moving parts to make this happen, but the basics are just a piston moving up and down inside a cylinder. There are 4 strokes or movements of the piston that keep the engine running. On the intake stroke, the piston moves down and the intake valve opens, allowing a fuel-air mixture to enter the cylinder. At the top of the cylinder, the mixture is compressed and then ignited by the spark plug. This is called the compression stroke. Once ignited, the mixture explodes, forcing the piston back down in what is known as the power stroke. Finally, on the exhaust stroke, the piston moves back up, pushing the burned gases out of the cylinder through the open exhaust valve. And that's one cycle of a 4-stroke engine. In addition to these 4 strokes, 2-stroke engines exist and they don't have valves or a crankshaft. Instead, they use a reed valve to control the flow of fuel and air into the cylinder and a rotary disc to transfer power to the crankshaft. 2-stroke engines are less complex than 4-stroke engines, but they're also less efficient and produce more pollution. Once the engine has started, power is transferred from the crankshaft through the transmission to the wheels, which are connected to the car's differential. The differential allows the wheels to rotate at different speeds, which is necessary when the car is making turns. Power is delivered to the wheels through the drive axles, which are connected to the differential. If the car has front-wheel drive, power is delivered to the front axle, which turns the front wheels. If the car has rear-wheel drive, power is delivered to the rear axle, which turns the rear wheels. Most cars today are front-wheel drive because it provides better traction and handling. When the driver wants to change gears, they have to engage the clutch, which connects the engine to the transmission. To do this, the driver uses the clutch pedal, which is located to the left of the brake pedal. When the clutch pedal is pressed, it disengages the clutch, allowing the gears to be changed. Once the desired gear is engaged, the clutch pedal can be released and the car will move forward. To slow down or stop the car, the driver applies pressure to the brake pedal, which activates the brakes, which are located on all 4 wheels. When the brakes are applied, the wheels lock up, preventing them from rotating, which slows the car down. Most modern cars have anti-lock brakes, which prevent the wheels from locking up and allow the car to be steered while braking. Anti-lock brakes are important for safety because they allow the driver to maintain control of the car while braking hard. ABS sensors monitor the rotational speed of each wheel, and hydraulic pressure is used to quickly pump the brakes, preventing them from locking up. Another key component of the braking system is the brake booster, which helps the driver apply pressure to the brakes. The brake booster is a vacuum pump that creates a partial vacuum in the brake lines. When the driver presses the brake pedal, the vacuum helps to amplify the force of the pedal, making it easier to press. But what about steering? To steer the car, the driver turns the steering wheel, which is connected to the car's steering system. The steering system includes a series of gears and shafts that are used to turn the wheels in the direction that the steering wheel is turned. The steering wheel is connected to the steering column, which contains a shaft that runs from the steering wheel to the steering gearbox. The steering gearbox is connected to the car's front wheels by tie rods. When the steering wheel is turned, the shaft in the steering column rotates, which turns the steering gearbox. This, in turn, turns the tie rods, which are connected to the wheels. To keep the car stable and balanced, there are several springs and shock absorbers that are attached to the car's frame. These help to absorb shocks and bumps in the road, making for a smoother ride. The springs are attached to the frame and the wheels. When the car hits a bump, the spring compresses, absorbing the shock. Then, as the weight returns to normal, the spring expands, releasing the energy. Shock absorbers are also attached to the springs, and they help to dampen the oscillations of the spring. They're essentially pistons that move up and down inside a cylinder filled with a viscous fluid. As the spring compresses, the shock absorber moves up, forcing the fluid to flow through a small orifice. The resistance of the fluid causes the motion of the shock absorber to slow down, which reduces the oscillations of the spring. So now we know how a car moves and stops, but what about turning? To make a turn, the driver must first reduce the car's speed by applying the brakes. Once the car is slow enough, the driver can turn the steering wheel in the direction they want to turn. The steering wheel turns the front wheels, which makes the car turn. Okay, so let's take a look at the inside of the car. The driver sits behind the steering wheel and controls the car with their hands and feet. To the right of the steering wheel is the instrument panel, which includes the speedometer, which shows the car's speed, and the tachometer, which shows the engine speed. Below the instrument panel are the controls for the car's various systems, such as the radio and air conditioning. The center console contains the gear shift, which is used to select the gear that the engine is connected to. The seats are where the driver and passengers sit. They're usually covered in fabric or leather, and they provide support and comfort for long drives. The windows are made of tempered glass, which is designed to shatter into small pieces if the glass breaks. This helps to protect the occupants in the event of an accident. The doors are made of metal, and they provide access to the interior of the car. They also help to protect the occupants in an accident by providing a rigid structure that can absorb the impact. One of the most important things to remember about cars is that they are machines that convert fuel into motion. They do this through a series of controlled explosions that occur in the engine. The engine is connected to the transmission, which allows the driver to control the car's speed and direction. The transmission is connected to the wheels, which are in turn connected to the car's steering system. The steering system allows the driver to control the direction of the car. The car's braking system allows the driver to slow down or stop the vehicle. It's made up of several components, including the brakes, which are attached to the wheels, and the brake booster, which helps the driver apply pressure to the brakes. The car's suspension system allows it to move over bumps and other obstacles without being thrown off balance. It's made up of springs and shock absorbers that are attached to the car's frame. All of these systems work together to allow the car to move, stop, turn, and ride smoothly over a variety of road conditions. Hopefully, this gives you a better understanding of how cars work. Next time you get in a car, take a moment to appreciate all of the complex systems that are working together to allow you to move from one place to another. Many real-world situations involve more than just moving objects. Sometimes you've got to find the area of a region or the volume of a solid. That's why Brilliant has a course on multivariable calculus. You'll learn how to find areas and volumes of different shapes and solids by breaking them up into smaller pieces and adding their areas together. So sign up with Brilliant today and learn more about multivariable calculus. Thanks for watching this episode of Crash Course How Do Cars Work, which was filmed at a studio and made with the help of all these nice people. If you want to help keep Crash Course free for everyone forever, you can join our community on a crowdfunding platform.